Hey everyone, and welcome to This Explainer. Today, we're going on a seriously fascinating journey into one of the most intriguing mathematical paradoxes hidden right inside the everyday world of business costs. If you've ever wondered how a business actually scales, or how math perfectly describes the messy reality of manufacturing, well, you're absolutely in for a treat. We're going to unpack a concept that sounds super simple at first, but behaves in a way that is just kind of mind-bending. Get ready to explore the never-ending slope of the average fixed cost curve. So, I want you to start by pondering a little riddle. Can a business cost fall forever, literally getting continuously smaller and smaller, but never actually reach zero? How can something constantly decrease, but mathematically be completely forbidden from ever disappearing? This is the core mystery of what we're going to call the journey of infinite approach, and by the end of this explainer, you'll understand exactly how and why this whole shebang works.
Let's kick things off with Section 1, the unavoidable fixed cost.
Okay, let's jump right in. To understand this math paradox, we really have to ground our abstract concept in the day-to-day reality of running a business. See, before a factory produces a single item, before the machines even get turned on, there are costs that just exist. We're talking about factory rent, insurance premiums, property taxes, you name it. We call this total fixed cost, or TFC for short. Now, think of TFC as a perfectly straight horizontal line. Even at zero output, that massive bill is just sitting there. It's a constant. As you move forward and actually produce more, that total fixed bill simply doesn't budge at all.
Moving right along to Section 2, defining average fixed cost. So businesses don't just look at their total bills, right? They absolutely need to know how that cost impacts individual products. That's where average fixed cost, or AFC, comes in. It's basically the per unit cost. We figure this out by taking our total fixed cost and dividing it by the total output, which we'll call Q. Just think about the mechanics here for a second. The numerator is real money, like a $10,000 rent check. The denominator represents physical items, like the actual number of widgets coming off an assembly line. So what exactly happens when you divide a constant number by a number that just keeps getting bigger? Before we do the actual math, it's totally vital to clearly distinguish these two concepts in your mind. On one hand, you have total fixed cost, the massive, unavoidable block of money you owe, regardless of what you do. On the other hand, you have average fixed cost, the per unit burden that constantly changes with every single item you produce. So let's speed things up and watch this math in action. Imagine your total fixed cost is exactly $1,000. If you only produce one single unit of output, your average fixed cost for that unit is, well, the full $1,000. Ouch, but what if your output jumps up to 2 units? Now you divide that $1,000 by 2, and the average fixed cost drops to $500. Produce 10 units, the AFC plummets to $100. What if you produce 1,000 units? Boom, now your average fixed cost is just one single dollar per unit. Because that fixed total is being spread over a larger and larger quantity of output, the average fixed cost continuously decreases. It gets smaller and smaller, which is honestly a beautiful thing for a business owner's wallet.
All right, Section 3, drawing the never-ending slope.
How does this continuous decrease actually look when we map it all out? And this brilliantly illustrates exactly what we've been calculating. Picture a curve that starts incredibly high up on the left side, representing that massive per unit cost when you're producing almost nothing. But as output increases to the right, watch the curve swope downward. It drops steeply at first, then kind of flattens out, sloping downward continuously, because that same fixed cost is being spread over more and more units.
Which brings us to Section 4, the asymptotic mathematical reality. We've officially reached the climax of our whole narrative. The curve keeps falling, but it never actually ends. There is a beautifully precise mathematical term for this. Our source states that the AFC curve is asymptotic to the axes. Actually, quick side note here, if you're taking an economics exam anytime soon, explaining why the curve is asymptotic to the axes is a classic 3-mark question, so definitely lock this in. To be asymptotic essentially means to engage in an infinite approach. The curve gets closer and closer to the edges, the x and y axes, but it is mathematically forbidden from ever touching them. It's an eternal approach without ever arriving.
Finally, Section 5, why it never touches zero.
Now, math isn't magic. It's based on very strict logical rules. So why is this curve doomed to wander endlessly close to the axes without ever making contact? Well, we're going to break this untouchability down into 2 distinct steps to get you that perfect explanation. First, why it avoids the horizontal x-axis, and second, why it avoids the vertical y-axis. Let's tackle the horizontal infinite approach first.
So the absolutely crucial point is this. The horizontal axis represents a cost of 0,
Why doesn't the curve ever touch it? Just remember our formula. Average fixed cost equals total fixed cost divided by output. Our total fixed cost, that's the rent, the insurance, is always a positive number, right? Even if you produce millions or billions or literally trillions of units, you are still dividing a positive number by another positive number. And mathematically, dividing a positive number by any other positive number will never, ever equal zero. The fraction gets microscopically small, sure, and the curve gets infinitely close to the axis. But because the total cost remains a positive reality, the average cost can literally never be zero. Okay, now let's look at the other side of things. Why does it avoid the vertical y-axis? Well, the vertical axis represents an output of zero. If you trace the curve way back to the left towards incredibly small levels of output, the average fixed cost just skyrockets. If you only make a fraction of a unit, your cost per unit is completely astronomical. But because the total fixed costs has a real positive value even at the lowest possible output levels, the curve simply shoots straight up alongside the axis, getting infinitely closer but never actually resting on it. It is entirely bounded by the positive reality of fixed obligations at low outputs, exactly the same way it's bounded by the impossibility of zero division at high outputs. We've seen how the math perfectly dictates the reality of the business world today. The total fixed cost forces the average fixed cost into this beautiful asymptotic dance, always approaching zero, always getting more efficient, but never entirely vanishing. It leaves us with a genuinely fascinating real-world puzzle to ponder. If average fixed costs continuously approach zero but never actually touch it, at what point does producing just one more unit stop being worth the effort for a business? What really are the limits of infinite division out there in the real world? Think about that the next time you see a massive factory churning out thousands of products. Thank you so much for joining me on this explainer to unpack the never-ending slope. Keep learning, and I'll see you next time.